All righty, folks, how you all doing? We're getting ready to start our final unit here in calculus, so very exciting. You guys have done well to get to this point, and we're going to do well to finish it up. So today we're going to start something called differential equations. Now, differential equation is essentially an equation that's tied to a derivative, and so it deals with a rate of change. So the best way I think I can best describe it here is if we kind of jump into it a little bit, and then we'll see a little bit about what I'm talking about here. So let's say if y equals 3x squared is a solution to the differential equation of x, y prime. Oh, I spelled that wrong. That's fine. I'll go back and fix it here. Is y equals 3x squared a solution to the differential equation x, y prime equals 3y. So, in other words, we have this equation. We have x, we have y prime, we have y, and y. So, what we're looking at here is a differential equation basically makes some sort of, or the derivative will make, or a form of the derivative will make the equation true. So, if I take everything here and I plug it all in like this. And I already know what y is. So I can plug y in here. Y, we said it was 3x squared. So now in order for this to see if this differential equation is true, I got to figure out what y prime is. So I'm going to be dealing with this idea of a derivative. So differential equations are equations that come from the derivative of a function or some sort of equation. So y prime is 6x. If I plug 6x in here, whoop, what we're asking ourselves is this going to be the same? If I get the same thing on both sides, then y equals 3x squared is a solution to this differential equation. So is it a solution? Well, it depends. Do I get the same thing on both sides? So do a little arithmetic here. 6x squared plus 3x squared equals 9x squared. We end up with 9x squared equals 9x squared. So y equals 3x squared is going to end up being a solution to that differential equation, because when I plug the equation and its derivative in, it makes the differential equation true. So before we get going too far, we start playing with differential, general, and particular equations, I want you guys to try one of these yourselves to see how you do with it. If y equals sine of, or is y equals sine 3x a solution to the differential equation y prime times tangent 3x, that was supposed to be x, there we go, equals 3y. Is y equals sine x a solution to this differential equation? So again, we have to eventually go through here and we have to figure out what is the derivative in the function. So why don't you guys go and pause the video and let's see what you come up with. All right, let's see how we do. Oops, wanted that to be black. Let's see how we do here. So y prime, we're going to go and figure it out, times tangent of 3x and 3y. I guess I never did answer the top one. Yes. Y equals 3x squared is a solution. Should probably always answer a question. You guys are probably like, thought we were done with that one. Yeah, I did too. Just realized I never ended up answering it. Probably should do that. All right, anyways, we're back down here. I know what y is, so I'm going to plug that in. That was sine of 3x. What I don't know is what y prime is. So we're going to figure that out here. So the derivative of sine, we're going to do a little chain rule here. Derivative of sine is cosine. So the derivative of the outside times the derivative of the inside. So, or if I just rewrite this as 3 cosine 3x. So we plug it in here. And now we got to go through and simplify. Do we get the same thing on both sides? Is it going to be a solution? So 3 cosine of 3x times sine 3x over cosine 3x. So we get back into a little bit of a trig proof like we did last year. Not much. So we're not going to go too crazy with it. And when I clean up the left side, we end up with 3 sine of 3x because the cosine 3x's will cancel out. So sine 3x, 3 sine 3x, sorry about that, equals 3 sine 3x. So then we're going to write all about it. So this is just a real quick intro to differential equations here. It's basically, when a function in one of its derivatives or a form of its derivative is a solution to a secondary equation, which we call a differential equation. Now there's obviously a lot more to it. We have a whole class of mathematics called differential equations. Some people call it calculus 4 that deals with this whole idea. We're just dealing a very basic introduction to differential equations here in Calc 1, here in Calc AB. So the idea here is just, can we test, is an equation and its derivative a solution to a secondary equation, which we call a differential equation. So what we're going to end up doing with this, for us, we're going to go a little bit more. We're going to actually solve some differential equations. And the way we're going to solve them is I'm going to start off and I'm going to give you some sort of a derivative. Now, the biggest thing to remember here right now is it kind of looks like one of our implicit derivatives, and that's essentially what it is. What I need to do, though, is I need to get the dy all by itself. Because what we're going to do is we're going to integrate one side with respect to y and one side with respect to x. And we're going to come back in a few days and do things that are a lot more complicated with this. So even though it says dy dx, I can actually multiply that to the other side and essentially make that a differential. So by doing that, I end up with dy equals 2x plus 5 dx. So if I want to solve it, that means I'm going to take the derivative, I'm going to turn it into a differential on both sides, and to undo the derivative, I'm going to integrate both sides. Now, when I integrate this side with the dy, I realize that there is still a number in front of there. There's a 1. So when I take the integral of that side, I end up with y. And when I integrate the other side, just our simple integrals here, I get x squared plus 5x plus c. Don't forget c. C is extremely, extremely important. So now what we basically did here is we came up with the general solution to a simple differential equation. So that's what I'm going to ask that you guys do right now. I'm going to give you a couple simple equations, and I want you guys to come up with the general solution for them. General solution means you're going to have a plus c, you are going to leave it alone. So let's have you guys try. You can do that one, and then let's try this one as well. All right, why don't you guys go ahead and pause the video and see what you come up with. All right, so first up, I need to move my differential to the other side. A lot of times we'll call this something called separating variables. So we're separating the x's and y's, but we'll get into actual true separation of variables in a few days. Right now, we're just kind of getting ready for the gist of it. So we're going to integrate both sides here, just getting introduced to it, what a differential equation is. So we're going to solve. Oops, I need to backtrack, don't I? I could go right into y, but I have an issue. I have this 4x here. Better probably do a quick little u sub here to see if I can actually do this. So u equals 4x. Du is 4 dx. So 1/4 du equals dx. So real quick little substitution here. So we got dy equals secant squared of u times 1/4 du. And we will bring that 1/4 to the outside. And now we can integrate both sides, friends. So you get y equals 1/4. Integral of secant squared is tangent. So tangent of u plus c. And then we plug in what u is back into our equation. So 1/4 tangent of 4x plus c. All right, let's see how you did on this other one here. We multiply both sides by the differential, dx and dx. And when I do that, I end up with dy equals e root x over root x dx. And now we're going to integrate both sides. So, got a little bit of work here to do. I got some ugliness going on over here, so let's just make this e root x. So e x to the 1/2. And to get this root x out of the denominator, I'm going to call that x to the negative 1/2. I'm going to do a quick little u sub again here just for the fun of it. So u is x to the 1/2. du is 1/2 x to the negative 1/2. Well, there's my negative 1/2 right there. And I'm going to move my 2 to the other side. So 2 du equals x to the negative 1/2 dx. So we have e to the u times 2 du. And we'll bring the 2 to the outside. And I've made no secret about this year. E to the u, my personal favorite integral. So we end up with y equals 2 to the eu, or ew, plus c. And we substitute that back in there. So 2e to the x to the 1/2 plus c. Or another way to look at that is 2e to the root x plus c. So again, we're solving simple differential equations, and these are general solutions. Okay, so these were general solutions. The biggest thing about a general solution is that they have a plus c with it. Okay, so they got they got a plus c. They're not hard. We don't have to separate anything because all the x's are on one side. We just move the dx over and we integrate it. So the last thing we're going to do is finding particular solutions to simple differential equations. And this is basically where we solve for what c is. So let me show you how this works. You get something like this. Find the general solution to, and I'll throw that in here in a second, given y of 0 equals 5. So in other words, you're going to be given a differential equation to solve. But I'm going to have to give you a value so we can actually figure out what that c value is in our equation. So let's see if we can't do this here. First of all, we start off with doing the exact same thing we just did. dy dx equals 3x squared plus 1. And we are going to move the dx to the other side. So we're going to separate our variables. So we end up with dy equals 3x squared plus 1 dx. Now, in order to solve this, the AP board, the College Board, they make a huge thing, and rightfully so that if you're going to integrate this, you have to make sure that you put a c on here, because that's the value we're trying to find. If you don't put c, it doesn't matter what you do from here on out, you don't get any credit. So you have to make sure you put a c. So what we're going to do now is we're going to actually determine what this value is by plugging it in for x and y. By the way, we don't have to put a c on both sides because c just represents constant. So if I have a constant on the left and a constant on the right, when I combine them, I still end up with a constant value. So we only add c just to the side of the x. We don't need c on both sides. So what we're going to do here is we're going to take this value now, and we're going to plug in 0 in for all the x's so we can actually figure out what c is. So in place of our y value, I'm going to plug in 5 in for y, and I'm plugging in 0 in for x. And when we do that, we find out that 5 equals c. So now we can figure out, we can go from the general solution to the particular solution by taking our value of 5 and plugging it in for c. Now I have a particular solution. So what started off as a general solution. So this right here is called a general solution. Now we have a particular solution. General, because we have it in terms of C. Particular, because now we were able to solve and figure out what C is. Oh, though I did realize I put general solution here instead of particular. Probably should have done that. All right. So let's keep going, friends. Weird. All right. Let's see here. Let's find the particular. Let me give you a couple to try, and then we're going to go ahead and call it a day here. So first one I'll give you is find the particular. Wanted that to be black. There we go. Find the particular solution to our equation given y of e equals -2. And another one for you guys. Find the particular solution to whatever the equation is I give you, given y of 2 equals, I'm going to make it pi. So pi right here. What are the solutions I'm going to give you? Or the derivatives I'm going to give you? dy dx equals 1 over x. And this one over here, dy dx equals 1 over x squared plus 4. All right, friends, why don't you guys go ahead and pause the video and see what it is that you guys can come up with. Go for it. All right, let's see how you guys did. So we're going to take our equations here. So dy over dx. And I'm going to multiply the differential by both sides. And I end up with dy equals 1 over x dx. So we're going to integrate both sides, friends. And we end up with y equals the natural log, don't forget your absolute values, plus c. Okay, so there's my general solution. Now I got to go figure out the particular solution. So I'm going to plug -2 in for my y. Apparently I wanted to plug in -3 in for my y. Let's try that again. -2 equals the natural log of e plus C. So we're going to figure out what that value is for C. All right, so the natural log of E, well, that's just going to be 1. So that means I end up with a -3 equals C. So my particular solution then is y equals the natural log of the absolute value of x minus 3. All right, 1 to go. Let's see how we did. dy dx equals 1 over x squared plus 4. And we're going to multiply both sides by the differential again. And we end up with dy equals 1 over x squared plus 4 dx. So we're going to integrate both sides. And we end up with y equals, this is going to be an arctan, so 1/2 arctan of x divided by 2 plus c. Okay, so there's our general solution. Now we're going to go and figure out our particular solution. So we're going to plug pi in for y. Equals 1/2 arctangent and we have what? 2 in the numerator? Okay. Over 2 plus c. So pi equals 1/2 arctangent of 1. So the arctangent of 1, we have to evaluate that because it is a trig value. So arctangent of 1, that's going to be pi over 4 plus c. So pi equals pi over 8 plus c, and then move the pi over 8 to the other side, we end up with 7 pi over 8 equals c. So our particular solution then is y equals 1/2 arctangent of x divided by 2 plus 7 pi over 8. All right. So friends, got a real quick intro to differential equations and then finding general and particular solutions to them. So I'll see you guys in the morning. We'll talk more about this and just kind of continue working through this idea of differential equations. All right, talk to you later.